Hi everyone, this is Faster, Smarter Decisions with AWS Serverless Data Analytics, and thanks for coming to today's session. This is going to be about an hour-long session where we're going to cover Games Analytics 101. So if you don't know too much about AWS services or Games Analytics in general, that's totally okay. We're going to try and cover some of those points today, and hopefully you'll come out of this knowing a little bit more. So a quick introduction on who I am. My name is Dominic. I'm a solutions architect here at AWS, and I work specifically with games customers of all sizes. And I'm here representing Game Tech. What is AWS Game Tech? Well, whether you're a team of 1 or 1,000, the most important thing to you is creating a game that players are going to want to play. So how you get there is the real question. That's where AWS Game Tech comes in. Game Tech provides a robust and scalable set of solutions for every stage of your game's lifecycle, whether it comes to the AWS services that it's hosted on, Twitch integrations, or even our managed game services like AWS GameLift. Now, a quick agenda on what we're going to be covering today. We're first going to be covering the demands of data analytics in games overall. And then we're going to dive into building a data analytics pipeline and walking you through what an example of this process might look like. Then we're going to cover use cases in games from a couple of our customers that are building and using analytics pipelines on AWS today. And then finally showing off a real-time demo of what one game analytics pipeline that you might build would look like. And on the screen here, you can see this is going to be our mascot and friend today. This is going to be Debbie the Dev, and we'll dig a little bit more into her story later on. So, first thing we're going to talk about is demands of data analytics in games. What benefits do they provide, and what challenges do they solve? We're first going to start with a quote from Supercell, who is a well-known developer for titles such as Clash of Clans and Clash Royale. And here's Supercell's policy. Analytics can't make a hit game, but it can improve it. They regard analytics as a very important thing to improve their game and to retain players. They've been using analytics for a long time, and especially because they have games that have free-to-play models, it's really important for them to understand how their players are playing their games and to optimize their monetization through the use of analytics. We're actually going to take a look at Supercell's analytics pipeline later on in this presentation and dive a little bit deeper into their architecture. So first, let's cover the broad demands for analytics in games. The first is to create more engaging games. You can use analytics to inform the design of your game and make gameplay adjustments in an iterative manner to help make your game more engaging for a wider audience. The next is monetization, as I already mentioned in Supercell's case. The importance of this, again, is going to depend on what payment model or pricing structure your game is based on. Right? If you're like Supercell and you've got a lot of microtransactions, then monetization and analytics supporting that is going to be a higher priority for you versus if your game is just a one-time payment. The next is fraud and player investigations. So you can use analytics to discover unusual behaviors among your player base and use techniques like possibly machine learning to identify cheaters, bots, and create a better experience for all of your players. And the last category is performance and error reporting. This is all about looking at the underlying infrastructure or events that your game is emitting and understanding what errors players are actually coming across or experiencing and trying to minimize those as much as possible. So now we're going to actually dig into each of these a little bit more and try and get a better understanding of what we mean by them. So the first is creating more engaging games. And this involves something called data-driven game development, where you can use analytics and data that you're getting from players playing your game to actually improve your game design. So for example, right, you can visualize telemetry data to show where player deaths are occurring on a map and identify opportunities to improve the balance of that map. So for example, you maybe have a multiplayer online battle arena game like Dota 2 or League of Legends, and that has a slightly asymmetrical map. Well, you can use analytics to actually identify where the deaths are occurring most or kills are occurring most for certain characters and change the map design accordingly to improve balance and make the experience better for your players. Next is, again, monetization. As mentioned earlier, the importance of using analytics to examine monetization really depends on the payment model of your game. There are many techniques that can be used that probably go beyond the scope of this talk. However, many strategies revolve around something called segmentation, or creating cohorts. And this is where you divide your player base up based on statistics that you have on them into separate groups that you can generalize to be in a certain part of the player lifecycle. For example, having just purchased the game and are starting out, or maybe are a more tenured player and is willing to invest more time and more money into your game. You can use this technique to do things like encourage purchases by targeting them with advertisements or suggestions to buy items that fit the profile that you have put them into, right? What cohort are they in, and what items would they want to buy as a result? For example, maybe an early on player would be more interested in buying an XP boosting item to accelerate their advancement in the game. And finally, you can use segmentation to do things like targeted ads. So if you have an understanding of what a certain player likes or dislikes, then you can target specific ads at them, such as reward videos, for things that are more likely to turn into a conversion. So say you have some ads for puzzle games and you know certain players really like puzzle games, well, it's probably a good idea to show them an ad for a puzzle game because they're more likely to click on that ad and actually purchase that game and make investments there. So that's another way that analytics can be used to actually increase your revenue from your existing player base. So third is fraud and player investigations. And the reason that this is important is because cheaters, bots, fraudulent activities, this can all lead to negative sentiment about your game and cause players to leave more quickly, right? So to retain those players, you want to make sure that you're identifying those abusers and cheaters and making sure that you're cracking down on them. So using analytics, you can actually gain insight into the actions that are happening within your game to try and identify where this botting is happening or where this cheating is happening. You can use that to send people or actions into an investigation pipeline, whether this is automatic or backed by a team of fraud investigators. You can use these analytics to find these cheaters much quicker and act on them and crack down much faster. So an example of this could be you can use data to determine if a player's movement defies the in-game physics and create alerts off of that event. And maybe send that to like a live ops environment for your team to be looking at, right? So if you actually want some more information on how to do this, we actually have a talk today by Nick Walsh that dives a lot deeper into this topic. So if that sounds interesting to you, please go check that out. And finally, there's performance and error reporting. So a big part of data analytics is just understanding how well your game is playing from an infrastructure standpoint, right? You can use monitoring and logs to improve your game infrastructure, understand when your peak usage times are so that you can scale to match, understand important metrics like latency. For example, if you have a first-person shooter game where latency is very, very important to players' enjoyment of the game, then understanding what your latency is at all times is really imperative. So you can make actions accordingly if your latency is starting to get out of the expected or normal bounds. And you can also use similar techniques to analyze error trends that are happening within your game to see how many players are experiencing certain types of errors and if you need to take some sort of action. Great. So now that we've talked about some of the demands of analytics in games, let's actually start diving into what building a serverless analytics pipeline looks like. And at its core, analytics for games are not that different from analytics for other applications or other industries. You measure and track elements to monitor performance, understand customer satisfaction, monitor sales, and so forth. So what differs in a games analytics pipeline is the size of your company and the amount of investment that you can put into building out this analytics pipeline. You might just not have the personnel that has the experience or time or knowledge to do this, but you still want an analytics pipeline in your game. So what we're going to talk about today is a way of building an analytics pipeline that's serverless, which means that you don't have to manage infrastructure, and the amount of knowledge that you need to actually build out a pipeline is as small as possible. So in this story, we're going to follow the tale of previously mentioned and shown Debbie the Dev. Now, Debbie is a developer at Unicorn Games, and they're currently building flying robot unicorns in space. It's going to be a really popular game, but they want to make sure that they have an analytics pipeline to support it. And Debbie's specific goal in this whole challenge is to improve the level design of flying robot unicorns in space to make sure that their players are enjoying the game as much as possible. So that's her end goal. And we're going to follow her thought process and the journey that she goes on and find out what services AWS offers that can help her. So first, we just want to dive into what types of data does Debbie want to be collecting and looking at, right? We already talked about what the demands of data analytics in games are, but what data should we actually be capturing to meet those demands? So we kind of break this down into two categories. We've got user data and we've got performance data. So under user data are things like player analytics, statistics about players, social and community data, how those players might be interacting with one another. These could be things like chat logs, and then actually gameplay data, right? Events that are happening within the game that you might be interested to know more about and can do reporting on. On the other side of things, you've got performance data. So this is more on the infrastructure level or how the game is actually running. Wait times and delays, network performance and latency, application logs and bug reports, some of these items that give you insight into how well your game is actually running. Another thing that Debbie needs to understand is that data has a shelf life. Based on when you're looking at the data versus when it was generated, there's a change in the effectiveness of your decisions based off of that data. So if we look at this graph, we can see that the sooner that you look at the data or are able to understand the data from the time that it's generated, you gain more value off of decisions made off of that data. And what that means is that data pipelines generally end up splitting into two different parts. And that is a real-time data pipeline and then more of a batch-focused data pipeline. So in today's talk, we're actually going to be talking about both, comparing and contrasting them and seeing how they might differ. But whether you have a real-time pipeline or a batch pipeline, the basic anatomy and components of that pipeline are going to look very similar. So you can see here that on the left side, we've got these telemetry or game events that are being generated by the game client, or maybe it's your backend servers and services. So that's on the left. Our end goal is to create a heat map of one of the maps in Flying Robot Unicorns in Space and understand where the most player deaths are happening on that map. And if we understand that, hopefully we can redesign the map to be a better experience for players. So let's actually see what components go into building an analytics pipeline. Well, the first step is to ingest that data into the pipeline, right? You need some method of actually getting it into the pipeline. Then you need to store that data so that it's persistent and you're able to look at that in the future and do any transformations or anything you need on it, right? You need reliable storage. Next is the analyze phase, where you actually get a better understanding of what data you have, how it's structured, and maybe do some transformations of that data to make it more useful and relevant to you. And then finally, you have the visualize stage. And the visualization stage is where you're really starting to get insights out of the data. Maybe you're creating graphs or reports that you can look at to gain a high-level understanding of what's happening within your game and make decisions based off of that. For example, our visualization would be this 2D heat map that we've showing on the screen here. So let's start to get into this. The first step is ingest. So let's take a look at what Debbie's goals are for the ingest stage. So first thing she wants to do is make sure that she's ingesting game event data from her game into the pipeline. And she wants to be able to use this data for both real-time and batch analytics. Finally, she wants to be able to analyze this data as it comes in for the real-time case, right? Real-time, we're talking seconds to minutes. So it's really important that the analysis stage can happen in flight. So what is Debbie actually going to use to ingest data into her game? Well, the service that she can use to help with this is called Amazon Kinesis. And Amazon Kinesis makes it really easy to collect, process, and analyze real-time streaming data so that you can get timely insights and react quickly to new information, just like she wants to do. And there are actually a couple of different types of Amazon Kinesis. There's 4 in total, but we see with game developers that they're typically using 3 of these. And that is Kinesis Data Streams, which lets you capture, process, and store data streams with your own consumer applications. Kinesis Data Firehose, which makes it really easy to ingest data and store it in storage options on AWS. And then finally, Kinesis Data Analytics, which lets you analyze your streaming data as it comes in by running SQL queries on that data. So it's really handy for doing that analysis in flight. So now that Debbie knows what service she wants to use, how does she actually implement this? Well, what she does is Debbie configures a Kinesis stream by using the AWS SDK in the game backend or in the game client, and then write some simple code to send game event data to that stream. And we'll actually show an example of that later on. Great. So now that we've done the ingest phase, we move on to store. Now, let's see what Debbie's goals are in the storage phase. So she wants to store data in a centralized place so that she has unified access to a single source of truth and her data is not split up or siloed all over the place. She wants to be able to organize and partition that data however she wants, and she wants to make sure that that data is accessible and extensible through any analytics tool. Right, so in the future, if they decide to implement a new tool or something, she will always be sure that she can have access to that data. So you can store all of your data in something that we call a data lake. And a data lake is just a pattern for storing your data in a centralized repository for all different types of data in a raw format. So this can be very well-structured data that has a defined schema. It can be semi-structured data, so maybe something like JSON, or completely unstructured data. And examples of that could be like actual assets like images or videos or MP3 files. And you also want to be able to store data from different devices, like mobile devices for mobile clients, information from game servers or from backend services, right? Really, wherever the data is coming from, you want to be able to store it in this one central data lake. And in Debbie's case, she's going to use S3 as her data lake. S3 stands for Simple Storage Service, and it's our highly durable and available object storage in the cloud. So it makes a great choice for a data lake on AWS for those reasons. So how does Debbie actually implement this? Well, she creates a data lake in Amazon S3 by creating an S3 bucket. She sets that bucket as the destination for her Kinesis stream, and then makes sure that her Kinesis stream is actually partitioning that data by time as it dumps that data from the stream into the S3 bucket. And that's really it. So the third stage is analyze. And this stage actually looks a little different depending on the real-time pipeline or the batch pipeline. We've already touched on how the real-time pipeline might use Kinesis data analytics to actually analyze the data in flight. So Debbie's already set on that. What we need to focus on is how to do this in batch. And Debbie has to figure out what data she has and probably transform those data into a more usable format, something that's going to make a little bit more sense for her and her team. And then finally be able to prepare it for visualization later on to actually gain some real valuable insight from them. So let's take a look at her goals. Debbie has 3 goals in the analyze phase. First is to catalog that data. So she wants to be able to understand what her data looks like, how it's structured. And then second goal is to transform that data into a more usable form, right? Creating more meaningful fields or columns, and then also compressing that data into a more compact format, which is going to save on space and therefore cost. And then her third goal is to be able to quickly answer questions, right? She might not always want to create a dashboard or a report for a question that she might have. So she wants to have some method to be able to query her data and understand it if she just comes up with a quick question that she needs answered. So the first step is for Debbie to use AWS Glue. AWS Glue is a fully managed ETL service that categorizes, cleans, enriches, and moves your data reliably between different various data stores using ETL. And ETL stands for extract, transform, and load. So extracting your data from a data source, transforming it in the way that you want, right? Again, we talked about maybe creating new fields, maybe compressing that data, changing it into a different format, and then loading it into your target data store where you actually want that data to be sitting. And Debbie is choosing to use AWS Glue because it simplifies and automates a lot of the difficult and time-consuming parts of ETL, like data discovery, converting that data, and scheduling these job tasks. Glue does this automatically by crawling the raw data assets in your S3 bucket, identifying what format that's in, and then suggesting schemas that data can adhere to so that you can always come back to that data and query it how you want. And another advantage of Glue is that Debbie can actually adjust the automatic recommended transformations using her, albeit somewhat limited, Python and Scala knowledge. So how does she actually do this? Well, she runs a glue crawler on her S3 bucket, which discovers her data and recommends a schema to put on top of it. Then she develops transformation code by taking the recommendations generated by Glue and tweaking them to fit her needs. In this case, an example could be changing both kills and a death field into a single KD ratio column. That could be a really simple example of something that she might be interested in more than just those 2 fields separated. Finally, she can use Glue to deploy continuous jobs, so she doesn't always have to go back and make sure that this thing is running. She knows that those jobs will reliably be run every day, for example. So with that, we covered 2 of the goals, but we still have this third goal, which is to answer these questions that might pop up once in a while, right? For example, maybe the lead dev wants a quick answer to some question and she hasn't created a visualization for it. What is she going to do in that case? Well, Debbie is going to look towards Amazon Athena to help with this problem. Amazon Athena is an interactive query service that lets you run SQL queries against the data sitting in your S3 bucket. Athena is great for ad hoc queries and analysis, when you just need to know what data you have, what structure it's in, and you just need a quick answer. It's serverless, just like everything else that we're talking about today. So there's no infrastructure to manage. And more importantly, you only pay for the data that you query or that you scan. So it scales very well with the amount that you use it. So it's really good if you want to scan or query the data infrequently, or you're just doing some data discovery. If you're really trying to do something that would be better done by a data warehouse, then Athena might not be the right service for you. So how Debbie is going to use it is actually using Athena whenever she wants to quickly answer a question, right? Again, lead dev asks her something like, well, which monster are players dying to the most, or is the most dangerous? She can use Athena to quickly generate a SQL query and query her data and find the answer. All right, so we've gone through these first 3 stages and we've done all the hard work. Now we just get to the point of visualization, right? This is where all of our work pays off. And we actually get to see these results and generate some nice graphs and reports and dashboards. So again, we're going to see what Debbie's goals are in this phase. For the near real-time or real-time pipeline, she wants to create dashboards and be able to track metrics about her game so that she can make informed decisions as a live ops team of 1. Again, Unicorn Studios is really small, so she has to be able to quickly look at this and gain information. She doesn't have a whole team backing her. For the batch side of things, she wants to be able to create graphs and reports that are going to tell her more about the long-term facts about her game, right? Things that might have to do with monetization, player behavior over time, things like that are much more suited to a batch pipeline and the visualizations that come out of that. Another goal in the batch pipeline is she wants to use a BI tool that doesn't have high upfront costs or is as expensive as some other enterprise level business intelligence tools out there on the market. So let's see how she's going to answer these. First, we'll start with the real-time pipeline. So Debbie is going to set up real-time dashboards using a service called Amazon CloudWatch. Amazon CloudWatch collects monitoring and operational data in the form of logs, metrics, and events, providing you a unified view of all of the resources that are reporting to it. CloudWatch can detect anomalous behavior in your environments, set alarms, visualize logs and metrics side by side, and take automated actions so that you can discover things about what's happening in your game and take actions accordingly. For Debbie's purpose, she can use Amazon CloudWatch dashboards to watch all these metrics that her game is emitting, all these events that she's programmed her game to emit, and send these as custom metrics to a CloudWatch dashboard so that she can keep an eye on all of them. Finally, she can create alarms to automatically respond to events. So if she's set certain thresholds on metrics that she wants to keep a track of, if those ever go over the threshold, she can get a notification and respond as quickly as possible. So how does she actually implement this? Well, she's going to create a Lambda function, and Lambda is our serverless compute service. And she's going to create this Lambda function that sends these custom metrics to Amazon CloudWatch. She's going to apply that to the Kinesis stream so that it's going to trigger based on every record of data that gets put into that stream, and then craft dashboards in Amazon CloudWatch that show those metrics that are being sent in from that Lambda function. And here's a quick example of what that code looks like. It's actually very simple. Just 3 lines in this case. So the first thing you do is create a client using one of the AWS SDKs. In this case, we're using Boto 3, which is the Python SDK. So you can see we're creating the CloudWatch client and then defining this data object and pulling that out of the Lambda environment. So Lambda receives that data from Kinesis, and then you can choose to send that to CloudWatch using this last line here, where we're just putting that data very simply. And in this case, we're just sending that data as is, but you could also do some transformation within your Lambda function as well before sending that data off to CloudWatch. So that was it for the real-time visualization. For the batch, Debbie chooses to go with Amazon QuickSight to build her dashboards because she can easily begin creating sophisticated graphs and visualizations of the data she has stored in S3. And we're actually going to show this a little bit in the demo as well. A little bit more about QuickSight. It's a serverless business intelligence solution that integrates very easily with the AWS ecosystem. So it's quick to get started on it. And it also includes a pay-per-session pricing model, which means that Debbie isn't limited in the number of graphs that she can make, or there are no large upfront costs to stop her from using the service. In addition, Debbie doesn't have any machine learning expertise, but Amazon QuickSight actually has some built-in ML insights that can do things like forecasting or anomaly detection, which can be really helpful for things like understanding player spend and predicting that spend, spotting player churn, or automatically generating natural sounding reports every day without any input from her at all, just completely based off of that data. So that was it for the analytics pipeline. Hopefully you got some more understanding of what the stages were in a pipeline and what services might actually help to meet your goals. So now we're going to take a little look at some customers that are using these services on AWS today and dig a little bit more into their use cases. So the first one that we're going to talk about is Epic Games. Epic Games is obviously very well known for Fortnite, and they're collecting billions of records on a daily basis using these services. So they're using Amazon Kinesis to collect this telemetry data and storing 14 petabytes of data in an S3 data lake that they have on AWS. And they're using this data to perform analytics on things like how players are interacting with one another, how often players are using specific weapons, for example, or overall player strategies that are emerging from the gameplay. And they can use this information and send it back to their game developers to help them decide on what players might want more of or to guide their decisions on what they want to make next. The next example we're going to look at is Supercell. And remember, we looked at a quote from them earlier in the talk. Again, they're well known for their titles like Clash of Clans and Clash Royale. And they're also using Amazon Kinesis for real-time delivery of in-game data. In their case, 45 billion events per day. That's a massive scale. So it just goes to show how high Kinesis can actually scale up. And they're also using Amazon S3 to store 10 terabytes of game event data per day. So they're just ingesting massive, massive amounts of data. And a quote from Supercell actually is that Amazon Kinesis does a lot of the heavy lifting and lets Supercell focus on delivering games that delight players worldwide. So again, even large studios and developers like Supercell can gain advantage out of having these serverless services and not having to worry about managing infrastructure. So that's really, really powerful for them. And let's actually dig a little bit more deeply into their architecture. So you can see that Supercell has both a near real-time layer and a batch layer, just like Debbie created in our example. So their game is sending out these events from mobile devices. Those events are being collected and sent to Amazon Kinesis, which then branches into these two separate pipelines. So for the near real-time layer, they've got third-party integrations and dashboards, real-time analytics that are coming off of that, and their support teams can also look at that data to make decisions and help their players out. In the batch case, it's hitting an event consolidator, which is combining those events together and then compressing that into an LZO format before sending it off to Amazon S3 for storage. All right, so now we're going to show off a demo that's highlighting some of the things that we've talked about in this talk and show you an example of something that Debbie might have built. So here I'm showing off the sample game client that we've made. And this is based off of an open source Unity project called John Lemon's Haunted Jaunt. And this is just a 3D game tutorial that we took and modified to implement AWS so that we're actually sending data from this game client to our backend system in AWS. And we're going to show off what that architecture looks like right after we show you what's possible in this demo. So I'm just going to play the game here and show off a little bit of how it looks. So you can see here that we've got John Lemon here, our little character, and we can have him walk around this haunted castle, and there's various monsters and things that he can be caught by. So what we're interested in is seeing what happens when he actually gets caught by one of these monsters or wins the game. So in this case, we just got caught. And what this has done is sent an event to our backend system. So we can take a look now and see what these events look like in our analytics pipeline. So because we only have this game and it's not a real live game and people aren't playing it all the time, we're actually sending in some synthetic data to this backend. But you can see here that this is our CloudWatch dashboard that we've made. And it's made up of various graphs and widgets that are displaying different types of statistics that Debbie might be interested in if she were making her own dashboard, right? So we're looking at things like P90 wins and P90 losses and seeing that, oh yeah, players are experiencing a lot more losses than wins. That's very clear if we look at this graph over here where it seems that the majority of players are losing a lot more than they're winning. And we can see some other statistics like on the bottom right here on time played. So this is our CloudWatch dashboard, and it's refreshing every 10 seconds, and you can adjust the amount of time that it's looking back in the past as well. So if you'd like to look at these metrics over the past hour or even the past day, it's possible. For a live ops environment, usually you want to be getting data as quickly as possible and kind of looking to see what the pulse of the game is right at that moment. So in this case, we have it set to looking at the last 3 minutes. Now, this is an example of a real-time visualization dashboard. Let's look at the batch use case and see what that looks like. So here we are in Amazon QuickSight, and you can see here that we've generated a few different reports and graphs of things that Debbie might be interested in looking at. So if we look in the top left corner here, we have this gameplay summary, and this was actually automatically generated and then tweaked a little bit by us to show off some statistics that we might be interested in about our game. For example, we can see how many players have been caught in our sample game here. based on the data that we generated. And QuickSight has even generated this list of the top 3 most dangerous monsters and the 2 least successful monsters. So we can see in this case that the ghosts in the game are much more dangerous than the gargoyles, which makes sense. They're moving around. Players are more likely to get caught by them. And we can see in particular that Ghost 2 here has more than double the amount caught as Ghost 1. And if we look at some of these other records here, we can also see that. So in this case, we can see in this caught by graph that we've got Ghost 2 with significantly more catches than any of the other monsters. So already we're using these visualizations to start to get an understanding of our game design and say maybe Ghost 2 is OP and we need to nerf him. Some other statistics we can look at here, win-loss percentage, right? It's currently hanging around 26%. Maybe that's not our intention in the game. Maybe we want players to be winning a bit more often than that. And we've found that this low of a number causes a bad experience and frustration in players. If you look over here, we have a sum of losses by player ID. So we can see which players are losing significantly more. And that could indicate that they're potential targets for churn, and also that they're potential targets for us to target advertisements or items at them, right? These players are losing a lot. Maybe they need some extra help. We could offer them an item that would help them sneak around more easily, or have the monsters move slower, and maybe provide a discount on those items. So that's where the targeted ads can play in. Finally, just want to show off this heat map here. And this is an example heat map of something that Debbie might have wanted to create, right? This specific heat map is looking at caught at versus caught by. So what rooms players are caught in versus what monsters they're caught by. And you can see our hotspot here is, again, our infamous Ghost 2 catching people in hallway number 2, where he usually likes to hang out. So this could either mean that hallway 2 is too long or too narrow, or Ghost 2 is just too powerful in that area. We can start to pull out insights like these based on these graphs that we've generated. So that's it for the demo. We're going to go back to our presentation and show off a little bit of what the architecture of this demo looks like, and what AWS services were used to create it. So that's it for the demo. Now we're going to move on to looking at what the architecture behind the demo actually looks like. So first, we start off with the game client. Showed you the game client, and that's what's actually generating the events that we're sending into our analytics pipeline. From there, we're sending those events to an Amazon API gateway. You can think of this as just a front-end API that will take that event and use AWS Lambda to post it to an Amazon Kinesis data firehose. Once it's in Firehose, then it gets split into 2 different pathways, for the real-time and for the batch pipelines. So let's talk about the batch one first. Amazon Kinesis Data Firehose automatically dumps that data into Amazon S3, which then we categorize with AWS Glue, do any transformations that we need, and then use Amazon Athena to do data discovery, and finally use Amazon QuickSight to generate those visualizations and graphs that we showed. For the real-time pipeline, Kinesis Data Firehose sends data to Kinesis Data Analytics, which performs some SQL queries. In this case, we're just filtering out some data because we're not interested in everything we're sending in our payload. And then we use AWS Lambda to trigger off of those filtered records and send them to Amazon CloudWatch as a custom metric. And we can actually take a look at what that code looks like in that AWS Lambda function that's sending it. And it's actually pretty straightforward. So the code for this is to create a delivery stream client similar to the code that we saw before. We're using the AWS Python SDK also known as Boto 3, to create a client for Firehose. After that, all we need to do is put a record to that client that we just made. So it's pretty straightforward. We use the put record method and give it the delivery stream name and the data, and that's it. So that was everything that I have for you today. We're just going to quickly go over some key takeaways that hopefully you can take from this talk and apply to your own game. So you can use analytics to make fast, well-informed decisions to increase engagement, grow revenue, improve infrastructure, and identify fraud. And all of these things are going to help improve the design of your game to increase engagement with your customers, grow your revenue to help you monetize your game, improve infrastructure, which will help to make sure that you aren't overpaying on your infrastructure or that it will scale to meet the demands of your players, and identify fraud, which will help to improve your community and make sure that the game is an enjoyable place for all players. I hope you also take away that data has a shelf life and give you a few ideas on what data you might actually want to capture from your game or your backend that you can then use to gain insights out of and make decisions. And finally, I hope I helped you to understand how to build analytics pipelines on AWS and some of the services that might go into that and how they might fit together. So if any of this was interesting to you or you want to find out more about it, there's a few places you can look. The first is the blog post titled "Delight Your Players with Game Analytics." This is a great start to just learning about analytics in games on AWS and some of the benefits of it. A lot of that we've covered in this talk today. Then there's 2 trainings that you can take a look at by our training and certification team. And those are Why Analytics for Games, which again gives you more motivation behind the reason you would want analytics in your games, and Building an Analytics Pipeline for Games, which will be a training that will teach you to build a pipeline that was similar to what we showcased in the demo today. Next, there's a Serverless Data Analytics step-by-step workshop, which will help to build a solution very similar to the one in the demo. And this is a step-by-step guide so that you can run through these services, get hands-on, and get a better understanding of them for yourself. And finally, we have a Serverless Data Analytics solution for games, which will help you jumpstart your own data analytics solution in your games, get something up and running that you can then take to modify for your own purposes. And that's it. Thank you guys so much for tuning in and listening in on this. Please explore the other talks and demos in today's event. And if you have any additional questions, please stop by the Ask the Expert section and speak with the AWS technical experts that will be there. And for any more details on serverless analytics in games, check out the Resource Center, which will contain all of the links from the call to actions that I mentioned before. Thanks, guys. Game on.